Have you ever wondered what time feels like on another planet? Not just how long a day is or how long a year lasts, but whether time itself moves differently. It turns out it does. And on Mars, time actually travels faster than it does here on Earth. Today, we're breaking down the science behind this bizarre reality. From Einstein's timeless theories to new research from the National Institute of Standards and Technology. By the end of this video, you'll understand why clocks on Mars tick nearly half a millisecond faster every single day, and why this tiny difference could cause serious problems for future astronauts, communication networks, and interplanetary GPS systems. Let's start with the headline. Time passes 477 microseconds faster per day on Mars than on Earth. That's 477 millionths of a second. Tiny but crucial. Scientists Neil Ashby and Baidyanath Patla at NIST calculated this difference using Albert Einstein's general theory of relativity, revealing how gravity and motion affect the passage of time. But here's the twist. Although Mars orbits the Sun slower than Earth, its weaker gravity and more eccentric orbit actually make its clocks run faster. To someone standing on Mars, a second feels perfectly normal. But from Earth's perspective, that same second passes just a sliver faster, a difference that builds up day after day. To grasp why Mars experiences faster time, we need to revisit Einstein's idea of time dilation. According to relativity, the stronger the gravity, the slower time passes. The faster you move, the slower time passes. This explains famous paradoxes, like the twin paradox, where one twin travels near the speed of light and returns younger than their Earth-bound sibling. It also explains black holes, where gravity is so strong that time practically stands still. So what does any of this have to do with Mars? Well, Mars has 5 times weaker gravity than Earth, a more elliptical orbit, and a varying distance from both the Sun and the Earth-Moon system. Put these together, and the Martian clock ticks just a little faster. Gravity is the biggest player here. Because Mars is smaller and less massive, it doesn't pull on objects or clocks as strongly as Earth does. And Einstein predicted exactly this. Weaker gravity equals faster time. That means that minute by minute, day by day, time on Mars slips ahead. Not by much, but enough that scientists need to track it precisely if we want Mars missions and future colonies to function smoothly. Gravity isn't the only factor. Mars' orbit is noticeably more eccentric, more stretched out than Earth's. That means when Mars gets closer to the Sun, it speeds up. When it moves farther away, it slows down. This variation affects the rate at which time flows on Mars compared to Earth. The NIST team found that the clock difference can fluctuate by up to 226 microseconds, depending on where Mars is in its orbit and how its motion interacts with the gravitational fields around it. In short, Mars doesn't just run fast, it runs unevenly. It speeds up and slows down, dragging time with it. Here's the fascinating part. Astronauts living on Mars wouldn't feel a thing. Their hearts would beat normally, their clocks would appear normal, and a second would feel exactly like a second. So how will we notice the difference? From Earth. Imagine 2 clocks. One sitting on your desk on Earth. One ticking away in a Martian research habitat. After just one Earth day, the Martian clock would be ahead by 477 microseconds. After a year, the difference would add up to 174 milliseconds. Enough to interfere with signals, coordination, and navigation. And that brings us to the next major challenge. Small timing errors might not seem like a big deal, but for modern technology, they're catastrophic. For example, 5G networks require timing accuracy within 1/10 of a microsecond. GPS relies on extremely precise clock synchronization. If our future Martian colonies use their own networks, even slight timing drift could scramble. Navigation systems, rover communication, satellite signals, data relay between Earth and Mars. This is why scientists are studying the problem now, decades before Mars is populated. As Ashby explains, we're preparing for the moment when other planets need their own navigation systems, and those systems rely on accurate clocks. Mars isn't the only world with strange time behavior. Scientists also calculated that clocks on the Moon tick 56 microseconds faster per day than those on Earth. The takeaway is clear. As humanity expands into the solar system, every planet will need its own time standard, and those systems must be carefully synchronized. Patla puts it perfectly. This is the closest we've come to realizing the science fiction vision of spreading across the solar system. We're entering an era where time is no longer universal, where each planet, moon, and spacecraft may run on its own unique clock. Mars is just the beginning. Understanding how time behaves across space will shape interplanetary internet, space-based navigation, future lunar bases, human settlement on Mars, and communication across billions of kilometers. It seems strange, but as we venture farther from Earth, our future depends on mastering something as simple and as mysterious as time itself. So now you know, time on Mars doesn't just feel different, it is different. Thanks to Einstein's relativity and new research from NIST, we're finally understanding what it means to keep time across the solar system. If you enjoyed today's deep dive into the science of time, space, and the future of humanity beyond Earth, make sure to like, subscribe, and share this video. And let me know in the comments. Would you live on Mars if it meant your clock ran faster than everyone on Earth? Thanks for watching.